Hello, welcome to GES Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 6 on investigating angles formed at a point by straight lines under Plane Geometry 1. I am Professor Christopher Opoti, your facilitator. We start to motivate the class, we start to make the class interesting and reduce tension by a riddle. Riddle. I am a figure. You can form me by joining two rays. These rays are called the size of me. My size share a common point. People usually call this endpoint my vertex. Who am I? We take the riddle again. Riddle. I'm a figure. You can form me by joining two rays. These rays are called the size of me. My size share a common endpoint. People usually call this endpoint my vertex. Whom am I? Yes, the answer is angle or an angle. Now, we do this following activity. Using two sticks or broomsticks as your rays, build the figure described in the riddle. Yes, take your sticks. I've taken mine, two sticks. So see how you can form angles with the two sticks. So I am forming mine here, and you can see it. I form this. It can be this. It can be anyhow you get the intersection. Now let's look at the possibilities. This is one possible angle you can form. A second one, a third one, and a fourth one. You can form as many you wish with these two sticks. Now, we are going to form another one using 3 sticks to form 8 angles. Now we can demonstrate using 3 sticks. So these are the 3 sticks to form 8 angles. So if we arrange them in this form, we shall have this across it anyhow, and we can find the 4 angles here at this spot, another 4 angles at this spot to form the 8 angles we are expecting the 3 sticks to form. Our learning outcome, we will be able to investigate the properties of angles formed at a point and explore the concepts of relation between angles. Outline of the session, Plane Geometry 1, we're going to look at investigating angles at a point, calculating angles at a point, corresponding angles, vertically opposite angles, alternative angles, and adjacent angles will be noted. And then we look at complementary and supplementary angles. As we move along, these keywords will be known or will be used. Parallel lines, transversal lines, corresponding angles, vertically opposite angles, alternative angles, adjacent angles, complementary angles, and supplementary angles. Now let us investigate angles on a straight line. Now when we have a straight line, KOL, and then we get it intersected at point O, OM, we have these two angles, the angle A and B. Now if we measure them by our protractor, or we cut the angles and place on the protractor, we are expected to get this result. So we may see that angle A plus B is equal to 180 degrees, and this will let us conclude that 2 or more angles on the straight line add up to 180 degrees. We can do the same for 3 angles on a straight line. and we cut the three angles and measure them on a protractor, we will get the same 180 degrees. Now, with the concept of this, we're using it to solve this problem to find unknown angle on a straight line. So find the value of x in the diagram below. Now, from our concept of algebra, we will be able to set our solution in this form. So we have x plus 84 equal to 180 degrees. Bear in mind that this 180 degrees is not part of the question, but it's something you should know before solving. So you should be in your mind from the concept that the angle of a straight line is 180, and that is what will help you to solve this question. And that is the problem of mathematics. Some of the known facts are not in the question, and you should remember to get them in. So we solve it, and by solving, we get x equal to 48 degrees. Let's look at another investigation at a point. And what do we notice here? Realize that when we have a straight line and we have angles at the upper part and angles at the lower part of that straight line, we have already known that the angle of a straight line is 180. So 180 degrees at the upper part, and the down part too will be 180 degrees. So we can say that A plus B will give us 180 degrees, and angle C plus D will give us 180 degrees. Therefore, if we are looking for the sum of all the four angles, it will give us A plus B plus C plus D equal to 180 plus 180, which will be equal to 360 degrees. So we can then say that an angle at a point can be found to be twice the sum of angles on a straight line, which we can say that it is 360 degrees. Now we can use this concept also to do this calculation to find the unknown. So here we are finding the unknown y, and by the same concept of knowing what the angle of a point is, which is 360, we employ it in solving this question. So we may have 65 degrees plus 90 degrees plus 32 degrees plus y equal to 360 degrees, and then we solve it with the algebraic concept we have learned in the various lessons, or the past lessons. We then have our angle y to be equal to 173 degrees. Dear students, I hope you can do this when you meet other questions related to this. Now, so summary of angles at a point and on a straight line. When we look at this drawing, angles measured in degrees, which is a measure of circularity or rotation. A full rotation, which will bring you back to face in the same direction, is 360 degrees. A half circle is therefore 180 degrees, and a quarter circle or right angle is 90 degrees. This is a summary of that. Now, we move on to develop the concept of corresponding angles, vertically opposite angles, alternative angles, and adjacent angles. And from the activity we did with the broomsticks, that is the drawing we have on the board. So students can use the broomstick activity to draw this, and they will get these values there. Now the line crossing the two parallel lines, we call it transversal line. So the two lines we see there are parallel, but the one crossing them is the transversal line. And now let us look at those angles which are corresponding and which are vertically opposite, alternative angles, and the adjacent angles. So identify various angles that are equal. Here, alternative angles, we have A equal to G, B equal to F, C equal to E, and D equal to H. We can notice that where the angles are on the drawing, they resemble Z. So if you take, for instance, C and E, you can draw the shape Z in it. So some call it Z angles. So if you see or somebody saying that what are the Z angles, they still mean to say alternative angles. Now, vertically opposite angles. They are angles that are directly opposite to each other. So we can find A to be equal to C, B to be equal to D, E to be equal to G, and F to be equal to H. We can now look at corresponding angles. Now, corresponding angles, they are found on the two parallel lines, but the position is maintained from one parallel line to the other parallel line. So if we look at where angle A is and that of E, their position is similar, but only on two different parallel lines. So we can say that angle A is equal to E because they are corresponding angles. Angle B is equal to H, C is equal to G, and D is equal to F. Now we look at adjacent angles. Now adjacent angles, simply we can say that two angles that are close to each other, they may be equal to 90 degrees, they may be equal to any 180 degrees or any angle so far as they are adjacent to each other. So we can say that adjacent angles are not necessarily equal. Now A and D are adjacent. We can see over there. B and C are also adjacent angles. A and B are adjacent angles. C and D are also adjacent angles. Can you go to the other point, my dear student, to tell me what angle is adjacent to E and what angle is adjacent to G? You can do this and with your friends by you, and then you'll be able to understand the concept of adjacent angles. Now we move on to talk about complementary angles. And in this wise, we are saying that any two angles that we add up to 90 degrees are called complementary angles. So if you have 30, 60, they sum up to 1, they are complementary angles. You have 15, 75, they sum up to 90. They are complementary angles. But we can make small distinction here about adjacent angles within it. Now, complementary angles are not always adjacent angles. From the drawing we have on the board, 75 degrees is close to 15 degrees, so we can say that it is adjacent. So we can call it adjacent complementary angles. However, when we get to the second drawing, 30 degrees is not near 60 degrees in the drawing. So we can call it non-adjacent complementary angles. Dear student, I hope this is clear so that you know the difference between adjacent complementary angles and then non-adjacent complementary angles. Now let's look at supplementary angles. Here also we are talking about two angles that add up to 180 degrees. So any two angles that add up to 180 degrees, we call them supplementary angles. We can see also here that supplementary angles may not always be adjacent angles. In our drawing, we can see on the board that 120 degrees and 60 degrees are adjacent. So we can say that they are adjacent supplementary angles. But on the other diagram, 30 degrees and 150 are not near to each other, and therefore we can say that this is non-adjacent supplementary angles. And dear student, with the ideas you have gained, this is a task that you should do Try these tasks wherever you find yourself, whether at home, in your school. So find these values. Find angles A, B, C, D, R, S, P, and Q in this drawing. And I hope by using the concepts we have developed from the beginning, you'll be able to answer these questions successfully. Thank you for listening. I believe you have learned something today. We have investigated angles at a point, calculated angles at a point, identify corresponding angles, vertically opposite angles, alternate angles, adjacent angles, complementary angles, and supplementary angles. So, dear student, I'll meet you in the next lesson. Thank you.